Hello friends, this will be my last video in search of a permanent mold using refractory cement. In previous videos I found that the complex figure I was using was not delivering the expected results, not the same results I had achieved before using a more simple model like this one. I couldn't get the model out of the mold without breaking it or burning it. In the next video I used silicone to create a wax model that was easy to get out, and with that create a mold in refractory cement. However, in this case I could not remove the aluminum end product without damaging the mold made of refractory cement and silica sand. The cause of this was the complexity of the model I was using and the weaker mold due to including silica sand in the mixture. In this video I'm going to use two models. The very complex model, fine-tuned to make it easier to get out, plus this simple model to compare the results. Additionally, I'm going to follow a new strategy, a reversed strategy. Instead of making the mold of refractory cement, I'm going to make the model of refractory cement. With the silicone mold, I'm going to make a refractory cement model. With this refractory cement model, I'm going to create a mold of bronze. And that mold of bronze, I expect to use it to produce many copies in aluminum. Now, as this figure has very thin parts, it's very delicate, it breaks up quite easily, the refractory cement will probably break up just as easily. So I have to create this figure in refractory cement, but with a support that will hold it together. I will do that by pouring refractory cement inside the silicone mold and cover it all with refractory cement. So it's part of one big square. Before doing that, I have to cut a bit off the borders of the silicone mold so to increase or give it the best angle possible and cut off those parts that might be interfering with taking the model out. I'm going to do that now and then we'll come back. Okay, I finished cutting all the little borders, and you can still see that some parts might not have the right angle and need a bit of fine-tuning, but I'll do that once I have the refractory cement. What we're going to do now is we're going to start making the figure of refractory cement. The complex model, we put it with the image that we have to fill in with cement upwards. And when it's hard and solidified, we're going to have to pull it out that way. This block of wood is to establish where I'm going to pour in the bronze, and it has to go with an angle in that way and that way, so I can pull it out that way. You don't pull it out this way. Okay, now I'm going to fill this in with mixture cement, and I'm going to put this wire mesh to give it firmness, and I'm going to prepare the cement and do the filling in and vibrating in my workshop because it's easier to work there with the vibrator. The same with the simple figure. I've got the simple figure here with silicone. It's surrounded by a frame of aluminum to make it easier to take out later when I have to push it out the other way. Centered there and with a wire mesh.
The mixture is basically refractory cement and water. The difference with previous experiences, in this case I'm going to put much more water than or usually does put in the refractory cement, make it more liquefied. So first of all I want the mixture of water and cement to get into every little crevice it can, and once it's there, then I'll start vibrating and I'll throw a bit of cement over it so it starts getting more dense. And that way I hope that cement gets into every little corner and makes the model perfect, as well as vibrating with to get all the air out and get it well distributed along my model. Okay, now at this level I'll apply the vibrator. I think that should be enough. And we put the mesh and a bit of cement. Okay, the first thing I learned with a simple model is that the silicone model tends to float up to the top, and that takes material below the silicone, so it will be very difficult to pick it out on the other side. So we have to fix the model, the silicone, to the bottom of the mold where it should stay put. And the other thing is to separate the silicone mold from the mesh, because we don't want the mesh to appear where the bronze is supposed to go. We don't want any contact between the mesh and the bronze. So in this case, it's a big model. I'm going to make the mesh like a dome around the model, so it doesn't enter in contact with the silicone in any point. And the silicone, I have fixed it with some nails to the bottom, and also the wood piece I've also screwed it in. So I hope that with this experience, this case, things will come out much better. So let's first start putting the cement into where the figure is. There we are, full, vibrated quite a lot. Still a lot of bubbles coming up, and still quite liquid. It takes some time in drying, so I'm going to just leave it here till it gets solid. And that's it. Some days have gone by now, and the cement is hard. It's starting to dry out completely, but it still needs more time. However, I wanted to show you a few details that have appeared in this experience. In the small mold, as we saw when we were pouring in the cement, the silicone mold moved around inside the frame, and it got out of place, and as it wasn't fixed to the frame, it ended up on a corner and it's much too near the border here. So eventually when I get it out, when I get the cement out, I'm going to have to fill in this part with cement because it's much too near the border, and when I pour in the bronze it'll break there. And so I'll have to do an extra job with cement there. In this case, when I finished pouring in the cement, this ended up with cement all over here and inside on top of the silicone. Yeah? Now clear this up, and the cement isn't completely hard yet. It isn't completely dry. There's much humidity inside the cement, so we have to wait some time before I take it out. Yeah? But meanwhile, I've been clearing up the borders, those parts where it doesn't matter if I scrape it a bit. In this case, the silicone mold stayed in the position where I left it because I had fixed it with some nails. These nails are still there, and I have to take them out later on. But the silicone mold is in the right position. Now we're going to wait some more time before we start pulling out the silicone mold, or I might break the figures. This mold should be quite easy to get out because it is plastic. The cement doesn't stick on plastic, and just tapping it a bit gets the cement out. There we are. And we're going to scrape this here. Okay, that's how it should stay. Now I can use a bit of sandpaper to make it a bit nicer finish. But afterwards with the bronze, I can also finish it off with sandpaper and tools. But as is a great mold for preparing the bronze mold. This is a simple design and should work very well. Okay, it's ready to pull out, but I feel that it still is, it needs drying up a bit more. So I'm going to leave it there a couple of days before I pull out the silicone. I'll bring the camera over here so you can give a peek also. It looks quite nice. And now we're going to take off the silicone very carefully, making sure we don't drag anything off. We don't break anything. Okay, wonderful. There we are. See, there we have the fill complete. Now I'll have to sandpaper a bit, some parts, make sure that the bronze fills the spaces with the proper angles. That's what I'm going to have to do now. Sandpaper the angles. When I lift up the bronze mold out of this, it'll probably catch on in some parts and break the mold there. Once the aluminum I've poured into the bronze mold gets hard, it'll stick there. So I have to fix those parts in the bronze mold so the aluminum doesn't stick there. Okay? So it's important to reduce as possible any breakages here and mark them once I take the bronze out. I finished smoothing out the surfaces, making sure the angles were perfectly angled, they should be. And now I'm going to wait for it to dry a bit more, and then I'm going to torch it, burn a bit the surface so it's prepared to receive the bronze. The amount of bronze I need for this figure is about 500 milliliters of bronze. My crucible, my biggest crucible, just gets about 450 milliliters. So I've cut an old fire extinguisher. I put a base on it so it doesn't roll over, and I made a pair of holes here with some bolts that I'm going to use to pick it out of the furnace. So what I'm going to do now is I'm going to solder the bolts on so they don't move. Okay, here I've got a piece of iron, some magnets to hold in place, one connection here, and now that's about enough. That's about enough to stop it from turning or being pulled out. What I'm doing now is preheating the molds, preparing them to pour in the bronze. However, when I started doing this, I noticed that there's vapor coming out of the furnace, and that means that most probably there's moisture in the material, in the cement, because in winter there's much moisture in the environment, and these materials tend to pick up that moisture, and we have to get that moisture out. Get it as dry as possible before pouring in the melted bronze. I will show you how the vapor looks. I don't know if you can see it there. If it picks it up, yeah. There you can see some vapor coming out. I have to keep feeding it until all that vapor disappears. And then, just in that moment, we will be able to pour in the bronze. So, we'll have to wait a while. Okay. There's no vapor coming out anymore. It's heating up quite nicely. And I'll start off with a small mold that is very hot and is ready to receive melted drops. Now I'm going to start heating up the brass there, enough brass to fill this mold, and I won't be speaking anymore because now I have to use my I have to cover my nose and mouth for any toxic gases. I was short with the amount of bronze I used. Apparently, I'm going to have to add a bit more. Now, it won't stick on, so probably I'll have to solder it with silver solder. Let's see, we'll see what happens. Finished with this procedure and it's gone fine. So now I'm going to start off with the other one. Okay? First of all, I'm going to heat up the mold a bit more so it gets hotter. It's quite hot now, but it can get hotter. And then I will start with the bronze. There it is. Not perfect. There's a hole there that will stop the aluminum from coming out. That's due to having had to use two lots of bronze. If I had done it all in one piece, that hole wouldn't be there probably. But all the rest came out quite well. I'm ready to pour the bronze into the master mold. This is a real big amount of bronze, about 5 kilograms. To put that in that mold will do a very delicate job. So you have to be very careful. Huh? Let's see how it goes. Okay, that went quite well, despite I wasn't so careful. I must establish, before pouring in the bronze, I leveled the mold, putting some tacks there to keep it perfectly level, both this ways and that ways. That's very important to have a level mold. Now we're going to have to wait and let it cool off and see how the mold came out. Here you can see, and by pouring cold water onto the mold, the vapor that is created there pushes the mold out on its own. I don't need to use any instrument or break the full cement mold. It comes out practically on its own. And here we have our bronze mold, and of course cement mold that just cracked either with the change of the heat or because it got caught in the bronze. This is the mold, the bronze mold that I ended up with. You can see it's full of holes all over the place. Holes that go deep inside, and other holes that are just on the surface. These holes here aren't air bubbles from preparing the cement. All these holes refer to humidity in the refractory cement. Being still wet, still had humidity in it, it wasn't dry enough when I poured in the bronze. And the boiling bronze on cement, that moisture simply blew out, creating these eruptions, these holes that are very deep, and this is impossible to use as a mold. All the surface has been affected by the humidity evaporating and exploding. Now this mold, just like the small one, was 45 days drying. It's absolutely enough time for a mold to dry and be fired. The smaller mold, after 45 days, was perfectly dry, didn't suffer this problem, despite it was the same material, but as it was smaller, it dried up much faster. The problem is that we're in winter, there's much humidity in the air, and this material absorbs humidity very easily. So I should have kept on heating it up for a week or more before pouring in the aluminum. There's nothing I can do about that. Now I might be able to give this a nice finish and sell it as it is, but it's no use as a mold. The small mold came out quite fine. The surfaces, the internal surfaces of the mold, were very smooth, scarcely any obstruction. There were a few holes there due to having made it in two parts, but I filled in those holes as best I could using silver solder, and it was apparently it was a good option to test it. So I filled it with aluminum, but it is impossible to get it out. I have tried all options to get the aluminum out of here, but it is impossible. Except, of course, melting the aluminum, which is not the idea. Now, however, one could use this type of mold made in bronze just as permanent molds made of iron. That is, make the mold in two parts, as if cut down the middle. Simply get the two parts together, you clamp them, pour the aluminum, and then you take the clamps off and take the aluminum out. Now I'm going to cut this mold in half to see how easily the aluminum comes out of the mold. Here we are. I cut it all along the middle, and hitting with a hammer I was able to separate the mold from the aluminum. Another hitting this other section of the mold with a hammer would obviously take out the rest. After finishing this experience, there's a few things I believe I have to conclude. One thing is that when you put cement into mold with silicone and other objects, these should be fixed in the mold. If not, they'll move around, the silicone will float, and it'll ruin all the process. Surrounding the silicone mold with a metal frame, it helps pull out the silicone and avoids it getting caught in the cement. Pouring one cast on top of the other is a terrible idea. I made the mistake of not calculating the amount of material I needed by weight. I just said, oh, that's enough, and it wasn't enough. Always do your calculation by weight and volume clearly. The vibrator is not enough to eliminate bubbles in the refractory cement. Although these holes aren't bubbles, I did find a few bubbles produced while I was mixing it with water. So with refractory cement, probably a vacuum is absolutely necessary to avoid bubbles in any part of the surface. Finally, the cement stuck onto the mold and broke off the block, mainly for two reasons. One, there was a heat shock there while pouring in the bronze, and on the other hand, the cement figure has very fine details, very thin little parts, but all that break off very easily. So really, for a complex figure like this one, this procedure is not useful. For a simple figure like this one, maybe not so simple, it is possible to create a permanent mold using cement and bronze. Well, I hope you like this video, and if you did, please give it a thumbs up, share it, call your friends, subscribe, and thanks for watching. Bye bye.